Hello, everyone. Thanks for joining today's session. For enterprises that operate in regulated industries like financial services, compliance is not just important, it's existential. My name is Hassan Tariq. I'm a principal solutions architect with AWS, and I work closely with customers like Stripe on their AI/ML initiatives. And joining me today is Chrissy and Christopher from Stripe, who led the development of this solution. I'll let them introduce themselves when they take the stage. So here is the agenda for today. We'll start with covering some background context of why agents can be a good fit for compliance use cases, and then go over some background and challenges of the actual use case that compliance teams faced at Stripe, and then what solutions they implemented and the benefits they achieved from it. And ultimately, we'll end up by discussing what's next and some lessons learned along the way. So before I go into the details or we start talking about how agents can be beneficial here, let's take a look at what's at stake here. So according to a research study conducted by Forrester, enterprises spend around $206 billion per year globally on operations related to financial crimes, with North America alone spending around $61 billion to this total. Now, this is a very massive spend, but it reflects the complexity and resource intensity of meeting regulatory requirements. And this is not just a static number, it's growing. According to some compliance teams based out of Europe, they shared that the compliance regulations and the demands that they're getting from the authorities is increasing by up to 35% year over year. So this means they are working through these different cases and have to produce a lot of documentation and spend a lot of extra time doing that. And that's where, when Experian conducted a survey with these compliance teams, trying to figure out what type of tasks they perform, what type of documentations they need to do, they discovered that almost up to one-third of these tasks can be automated. So just imagine giving back 8 to 12 hours per week to these compliance analysts so they can focus more on strategic analysis and decision-making. And that's exactly where the agents can play a big role here. Think about the best compliance analyst that you work with. They're really good at asking follow-up questions and connecting the dots among various different data sources. So if agents can do the initial investigation and data analysis, these analysts can focus more on the complex decision-making and nuanced judgment calls. When these agents can do the heavy lifting of the analysis, initial research, it frees up a lot of the analysts' time, and they can scale up. They can perhaps review a lot more cases than they are regularly doing. It's like giving each analyst a dedicated and tireless research assistant. This whole process brings consistency to this analysis also, which means you're ensured that every case will go through this rigorous step process and none of the data sources will get missed. And while doing all of this whole process through agents, when the analyst is focusing on making the decisions, the agents are doing the documentation and preparing the audit trail for those decisions. So in short, Analysts focus on the why, whereas the agents focus on the what and how. So this is all great, but you need a very solid foundation for these agents to operate. And we will hear shortly from Stripe team how Bedrock provides this foundation. So now I will pass on to Chrissy to go over some background and discuss about the challenges that they faced.
Thank you, Hassan. How you doing? Happy holidays and happy Cyber Monday if you care about shopping or payments. So before I dive into our AI use cases, let's take a step back and talk about Stripe as a company. So many people know Stripe as a payment processor. Last year alone, we processed 1.4 trillion in volume with a big letter T. And that is 38% up year over year. And take a guess. So that number constitutes 1.38% of the global GDP. Wow. So we are great in payment processing. And we bring good vibes to our developers. These are all great. Over the years, we are also evolving into this comprehensive financial infrastructure platform. So our internet, which was invented in the early 90s, and it wasn't designed with a native protocol for payments. So Stripe built the financial infrastructure on top of that. And that is what's enabling the emerging protocols, such as Agentic Commerce Protocol, ACP, if you follow us closely on Twitter, now called X. So our platform is very modular, and you can choose exactly what you need. May it be global payments, moving money, or platformization of your money via Stripe Connect, or automating back office tasks like tax and billing. We handle the heavy lifting by integrating with local banks across 135 plus local currencies. And while doing all these, we're maintaining 5 nines uptime. And on average, we're processing over 500 million requests per day. And that number might just slightly went higher during this BFCM. If you are interested, please go to bfcm.stripe.com to look into further information. So definitely, we're solving very interesting engineering challenges. That is just a means to a bigger end. So you ask, what is a bigger end? Ta-da! The bigger end is our North Star, growing the GDP of the internet. Sounds amazing, right? So to realize this macroeconomic impact, we realized as a company very early on that we need the solutions to scale with our explosive growth without sacrificing safety and compliance. And that, my friends, bring us to the heart of our challenge that we're discussing today. So when you ask people, what is fintech compliance? Most people will say, well, just following the laws. But at Stripe, our answer is, it is a foundation of trust. It is a mechanism that ensures that our platform, to ensure that our platform ensures our innovative technologies follow the rules of global finance. We view trust as a unified responsibility with 2 critical dimensions. One is ecosystem integrity. We enforce know your customer, know your business, and anti-money laundering. This is to ensure our platform will never become a haven for crime. So think about this. If a sanctioned entity tries to use a fake identity to onboard to Stripe, our compliance engine would be able to block that instantly. You might think it's easy, but it is actually pretty hard in reality because these bad actors are smart. They're constantly evolving as well. And an equally important dimension is to protect our users. At Stripe, users first is one of our leading operating principles. And that's one thing I really love about Stripe. I've been with Stripe for almost 5 years, so I think we really, really care about our users. May it be adhering to GDPR for privacy or UDAAP for fairness, we ensure our users are never exploited or compromised. We realize that if we don't protect the people that rely on the system, building a perfect system does not have a lot of meanings. So to build up this very effective defense, there are 4 factors that shaped our approach. 1, growth. We're constantly growing into new industries and markets. That means onboarding new users fast and safe is paramount for us. And second thing is the scale required from a compliance perspective. So we need to do enhanced due diligence reviews at scale. So short form is EDD. And we do this so we can manage users' risk effectively. Third, we are always striving to reduce the time to do these reviews, to raise the bar for our operational excellence. The last, technology innovation. So this is where Agentic comes in. We want to completely transform the manual compliance review process and to build a solution to make it faster, more consistent, and infinitely more scalable. So, what is the core of our business challenge? Due to regulatory compliance requirement, we need to do extensive reviews for high-risk users. So think about this almost as a detective, right? So they're looking into some suspicious, individuals. They're trying to figure out, are they actually suspicious? So as you can imagine, this requires a lot of the investigation time. However, we're doing this every day. We cannot take a long time. So doing this in a timely fashion is critical for us. So to help you visualize the manual review process by completely done by human a little bit better, so I summarize there are mainly 2 blockers. One is from the manual process. We realize a lot of times our expert reviewers are acting as navigators. They're just like going through all these different systems, trying to gather and locate information instead of the analysts that they're supposed to be. So they're not really using their time to making high-value decisions. And the second thing is scalability and the jurisdiction hurdle. So the biggest bottleneck is the cognitive overload when switching between different jurisdictions. So let me give you an example of this context switching. Say an expert analyst can move from assessing an entity in California where the retrieval process is rather straightforward to evaluating a complex corporate entity in UAE or Singapore. So for each jurisdiction region, it requires a completely different mindset to decide what constitutes as a risk. Making it more fun, so the threshold of risk is a variable. The definition of a safe business is not static. One example for that is regulatory compliance. So for, for example, ownership transparency varies widely between high-risk and low-risk jurisdictions. So thinking about this, right? So your expert analyst is basically applying this ever-shifting rule sets constantly. And this is a very demanding and complex task. Sometimes can even be error-prone. Just maybe a little bit like more analogy to help you visualize this, right? So every year I go through this pain once during tax season. Like, you need to go through a lot of rules. And I'm only doing it for the federal and California. So imagine how much pain these reviewers are going through. So, bottom up, we are trying to maintain the operational excellence for regulatory compliance by navigating through this fragmented jurisdiction map. Just linearly scaling up our workforces with the complexity is simply just not the solution. So you might ask, what is a solution? If this is a quiz in college, I think you guys will all get perfect scores because Hassan kind of gave the answers away already. So to solve this, our solution is to build an LLM-powered AI research agent to do autonomous investigations. Here, the agent does the heavy lifting in 3 ways. So, number 1, async workflow orchestration. This enables parallel processing. So the agent can look into different aspects of the business in parallel instead of sequentially, like a human would do. Second, because we build this plugs directly into the existing compliance tooling. So it works nicely, fits naturally into the compliance workflow that our reviewers are used to. You don't need to train them to the new thing. And the last bit, very exciting, agents, they never sleep. They don't need to rest. Think about this feeling, right? If you have a Roomba at home, you turn a Roomba on and you go out and hang out with your friends, and when you come home, the home is already clean. That's an amazing feeling, right? So having an AI agent to do these analyses before you even open the ticket is exactly the same thing. It will do the investigation and summarize the insights before you even open the tickets. So this is a game changer. And now we have the AI agent to assist and the humans to maintain the final authority. So before I hand over to Christopher to do the deep dive into our solution, I want all of you to leave this room with at least 3 takeaways. And obviously, if you have more takeaways, that's a bonus for you. Kudos to you. So the number 1 is oversight. We use a human-centric validation. Here, we're not trying to use AI agent to replace the decision-making. Instead, we're using agents to empower that. And all the expert reviewers have configurable approval workflows. So the agents are there to assist, and the humans make the final call. And the second thing is, we, like Hassan mentioned, we keep a complete audit trail, and we record every single decision and then rationale behind it. This makes sure that we will have enough data to serve as a compliance-grade evidence. The last bit, so with all these agentic stuff we're doing, we supercharge our reviews to enable our expert analysts to go deeper, faster with all these pre-fetch analyses. So with all these things, this is ensuring that we're not just building for speed, but we're building trustworthy, auditable, agentic compliance solutions at scale. So now with no further ado, let me welcome Christopher to the stage to dive deep into our solutions.
Thanks, Chrissy. Hey, everybody. My name's Chris. I'm a data scientist at Stripe. I'm going to walk you through a little bit of the technical implementation, and let's just kind of roll through with what we're going to go through. So we'll start with kind of back to the problem setup of exactly what we're kind of trying to solve, why we're using agents, that kind of thing. We'll jump into the agent mechanics, kind of how it works under the hood. We'll talk about how we actually plug into the LLM, kind of the brain of the agent in this case. Next, we'll talk about kind of an interesting service that we discovered we needed as part of this journey. We'll finally zoom out, talk about the kind of Stripe ecosystem of agents, and then we'll get into the business side of the journey, the results, that kind of thing. So let's jump in. So let's start with the problem. We had this basically very, very long manual review. And I think the first thing we wanted to think about doing was just, boy, what if we just threw an agent at it and effectively just automated the whole thing? And that's kind of a nice fairy tale. But in our case, it wasn't really going to work. The problem is this. If you just took an agent and you threw it at this workflow, it'll probably spend a lot of time on things you really don't even need it to spend on. It'll kind of rabbit hole. And then it won't spend really any time on things that you needed to look at. I mean, this has regulatory reasons for existing. So we have things we need to look at in many cases. And so we realized early on, it kind of made sense to have rails for the agents. And so there's a little diagram on the slide there. It's kind of meant to show you that we effectively were able to decompose this really complicated workflow into effectively a DAG. And the DAG is effectively these rails that we can use for these agents. Now, we happen to use React agents. One nice thing about this kind of DAG deconstruction is the tasks become effectively bite-sized enough to actually fit in the agent's kind of working memory. They do have a kind of a limited amount of, thought processing, just the way we do. I can't keep everything in my head. And the reason we're even using agents in the first place, and I think this is important, is why not just use like LLMs or something like that? Well, I think the reason agents work well is because they can call tools. And I actually think that's the main value. I have a very biased perspective maybe on agents, which I'll share a little bit later, but I think that's why agents are even practical here, and we'll talk about that a little bit more. One interesting thing, and this goes back to the fact that, yeah, it would have been nice to just throw an agent at it and have it be done, but we actually keep humans in the driver's seat in this case. They're making all the decisions. Agents are just there to effectively inform our reviewers to make the best possible decision. They can use it or not. That's up to them. But this is very much still a human-driven workflow, and we still found a good way to make that work. So who wants to see the agent? Actually, I think I'm getting a call right now. What in the world? I think he just finished a case. What's that? You want me to tell him about Amazon Bedrock? You know what? I'm doing the presentation here, all right? All right. We'll get to it. Agents. All right, so we're using a React agent. Let's talk a little bit about what that is. I kind of think agents think a little bit like I might if I have a complicated problem. Someone might give me a question. We'll call it a query in this case, OK? Let's say it's like 10 divided by pi, OK? I'm not going to know that offhand. Some of you might actually know that, but I don't. So I'm going to call an action to use a calculator, and I'm going to wait for that calculator to come back as my observation. And at that point, I'm going to think if I now have the answer. Yes, I do. So therefore, I'm going to progress to this final answer stage. So really what we care about in our review is ultimately this final answer. That's really all we care about. What it does in the meantime is kind of an implementation detail to our project, I guess you could say. Now, in reality, and the reason we even use agents in this problem is that we have much more complicated queries than something like that. And so, look, I'm a data scientist. So maybe I get like an analytics ask or something like that. I might need a few queries. I have an idea of an initial query I'm going to do. That might be close to what I needed, but maybe I see some issues. Maybe I'm going to rerun that query a few times. And so you can imagine I'm looping through this thought, action, observation loop as many times potentially as I need. You can imagine, and this diagram doesn't depict it all that well, but you can imagine this could actually loop around forever, and then it would maybe be true AI, whatever you want to say. But at the end of the day, LLMs have a finite context window. And so this effectively becomes a bit of a challenge for us. So in our investigation, really the reason we're using agents is because we need it to rabbit hole sometimes. Sometimes we don't. We always need it to cover all the bases. And so when we're basically going deep down in some of these rabbit holes, these prompts can get very long. So one thing I like about this slide is it kind of depicts this kind of 1 plus 2 plus 3 plus 4 type of kind of behavior. So I'm not like a 10-year-old Gauss, but that looks kind of quadratic to me. So effectively what that means is that as the agent needs to dig deeper and deeper and deeper to answer a question, it's effectively getting a longer and longer prompt that you effectively are paying for every single time. And it's going to be actually a quadratic cost over those number of turns, I believe. If you think about the entire cost of your agent operation, you're paying for input tokens, you're paying for output tokens. And you can kind of tell here, probably you're going to be dominated mostly by the input tokens in this case. There is a solution, however, to this. I believe that solution today is in the form of caching. And so why is that a solution? Because if I don't need to reread that prompt every single time, it's almost as if I'm paying for that final prompt once, which is more of a linear situation, which is superior. And that's where we're going to get back to Bedrock. So Bedrock is our provider that we can utilize effectively for this kind of prompt caching. But that's not all I'm going to talk about on this slide. We do use Bedrock for our LLM provider. We also have our own internal Stripe services as well. So we use this, we'll call it the LLM proxy service for this presentation. I think one way it really helps out a lot, I think, on this project is that we have a lot of people using LLMs at Stripe. And so, what could happen is, I don't know, let's say another team's doing some testing, or maybe they're scaling up. That could crowd out my bandwidth on a potential LLM provider. And so by centralizing this proxy service, we can effectively solve this noisy neighbor problem to constrain basically those neighbors from hogging all the bandwidth I might need for this project, let's say. Now, there's other benefits too. Obviously, we have guarantees because we're doing it ourselves around kind of the availability of this service, et cetera. We can do authorization. We can make sure the right LLM is being used for the right use case. Maybe there's some LLMs we feel like is too sensitive to run certain data on, et cetera. And so this allows us to kind of funnel those use cases to the right place. Potentially, this service allows us to also configure things like model fallbacks as well if one of the model providers isn't, was out of bandwidth or something like that. So why is Stripe using Bedrock? And why, we're using AWS in this situation? I think one of the biggest benefits I see for this project is actually probably around the standardization of the privacy and the security. So I don't know if you worked at a big company before. Maybe you want to use this new LLM provider for your project, but then that's not going to work because it needs to be vetted by security. And one really nice thing about Amazon for us is that we effectively do that vetting once to get on that platform, and then it's effectively standardized there. So Bedrock provides us access to multiple vendors of models, and we get that kind of standardization of that security around that. The second point I want to say is more around kind of the bells and whistles that come along with it. So we've talked a little bit about the prompt caching already. That can save you a lot of money if you're doing some sort of agentic flow where you're doing multiple dives deeper into the data. I also think fine-tuning is a really interesting one too. And I know the vendors have been providing really good models lately, and so maybe it's kind of fell off the radar for a lot of people, but I see a big opportunity for this project, mainly because the vendor model comes with kind of unforeseen deprecation schedules, let's say. Let's say we want to be focusing on adding new questions, but oh boy, now this new model that we're having great success with is going to get deprecated. Well, I prefer not to have to focus on old questions. I want to focus on new questions. And so by fine-tuning, maybe I could claw back some performance think the bigger thing is just that we can now deprecate on our own schedule. And that seems amazing. So I love the bells and whistles that come along with Bedrock. That's been very helpful. I believe there's more as well. The last point I'll make is that it's really one API, but you're getting many models. So this kind of comes back to the standardized privacy and security thing, where you plug into it once. You don't have to have that overhead of basically, in this case, setting it up, connecting it, doing the integrations, et cetera. Another thing I'm going to talk about here is when this project started, we didn't have this service called this agent service. So why do we have it now? Well, because we didn't have it first, basically. What happened was we had this kind of classic ML inference system across Stripe. And the original plan was to basically hack in this kind of agentic workflow into this kind of ML inference system, thinking it's close enough, it's gonna get us there. And it was shot down quickly for very good reasons. And those reasons are mainly that it really requires a totally different set of hardware, among other things. So you can imagine with really traditional ML, you're really compute bound. If you think about it, let's say you're running an LM, well, you're going to need a GPU or maybe at least one GPU. If you're running something like XGBoost, you might want a lot of CPUs. But that is what you're waiting on. You're probably getting a pretty consistent latency with whatever that computation is. So you have very short timeouts, for example. You also have very deterministic control flow. The model always runs exactly the same way. And you're basically paying a lot for these machines. They're hard to set up. You're trying to minimize the amount of machines you need, et cetera. Agents are kind of the opposite in all those aspects. So agents, particularly if you're using a vendor model, you're just waiting for it to come back. You're waiting for the LLM to respond to you. And so you're actually not doing a lot of compute at all. You're just like waiting around. You need a lot of threads, a lot of lanes, basically, to wait around for all the different agents that might be running on the same machine. You can expect very long timeouts in some case. You can imagine, like, what if a tool call needs to call a database? Could be minutes. I remember when we had engineers like first spinning up this service, and they're asking me, how long of a timeout do you need? Like, is 30 seconds okay? And I was like, I think we're going to need like 5-10 minutes. So very, very different profile of compute. Also very non-deterministic. I mean, some answers it might know very quickly. It only needs one tool call. Some may need to loop around in that thought, action, observation loop for quite a while. So you don't know exactly how long it's going to take. Tiny machines might be true and might be false, but like, quite honestly, you really just need a lot of lanes to wait for network calls. So we'll talk a little bit about the history of this agent service. We'll start with like, there's almost like beginning of Q1, which isn't in here, which is like it didn't even exist, okay? And we didn't even think we necessarily needed it. We tried to hack it into our kind of traditional ML service. Again, that got shot down. But we realized it was going to be very impactful for this project. And we saw that it was going to be something that was going to generalize pretty well. And so, kind of miraculous, but we got this thing spun up in about a month after deciding it was really going to be useful. And we spun that up to quickly by just making it a little monolith with a very kind of, let's say, primitive API that kind of reflected the way we were hacking it into the ML inference system. So you can imagine an ML inference system, you're going to have some sort of classic like predict endpoint, let's say. In this case, we had this kind of synchronous, you're going to have to wait for it. If we go back to the React agent, let's just say you're giving it the query, and then the output is you're just going to wait until it provides that final answer. And that was enough for this project. It wasn't tremendously hard, I think, to get going, but I think it was amazing we got it up in about a month. So we started there in Q1. In Q2, we started polishing it a little bit. So we added ways to do evaluation for agents. We added in tracing so that we could more easily debug what's happening behind the scenes within maybe that thought, action, observation block in this case. And we had an interesting developer in Stripe that decided to actually spin up this like no-code agents kind of UI where people could just build their own agents, add whatever tools they wanted. And that enabled this kind of mass proliferation that we ended up seeing in Q3. So Q3, interesting enough, is where we started really pushing the boundaries of this project as well. And so we started hitting kind of the capacity limits, let's say, of this entire project. And so we ended up taking what was originally this kind of monolithic design and then allowing every single use case to spin up their own service. So that solved that kind of noisy neighbor problem within the agent service itself. Q4 has been a kind of interesting development on the functionality. And so you can imagine maybe this product requires more of a ML-inspired API, just kind of that predict endpoint. But there's a lot of use cases around just chatbots. And chatbots, you want to be able to interact with them. You want to be able to see kind of their thought process. You want to be able to see all the different logs of the chat, let's say. And so this new API kind of allows some of these kind of stateful streamed updates. So it really enables that. And what's interesting is this may be part of kind of the no-code agents approach, but boy, we have, I believe, like over 100 agents at Stripe. I did a recent change. They're all over the place. I might rabbit hole a little bit here, but I don't know if you actually need like 100 agents to be successful. I'll say, like, from my biased perspective of working on this project, I will say you could probably get by with like a shallow React agent, maybe like a deep React agent in some sense, maybe like a to-do list that can spawn sub-agents. But I would say the 100 agents may be an artifact of the fact that we allow people to really move quickly at Stripe. And there may be a lot of prompts baked in my opinion, to the agents to get to that number. But I don't know. That's just my opinion. All right. So let's zoom out a little bit. Talk about kind of the full ecosystem at Stripe. We'll start back with the reviewers. So remember that we talked a lot about agents, but actually the human reviewer is really the star here, and they're in the loop. They effectively interface with this whole system through their web UI, the review tooling, et cetera. And we talked about this big DAG in the beginning. Well, that review tooling is effectively the orchestrator of this entire DAG flow. And so you can imagine that maybe before the review even begins, we know we can kick off a lot of these agents to kind of front-run research for some of these questions. But as the reviewer progresses through the review, you can imagine what context may become available to actually answer deeper into that review. And so you can imagine that this kind of this review tooling application is what determines or what triggers effectively this agent to begin front-running some of this research. Now, the rest won't come as too much of a surprise because we've already kind of gone deep on all these little kind of pillars in here. The React agent basically interacts with the rest of the ecosystem through two ways. The first is this LLM client, which will hit our LLM proxy that we've talked about before. That'll handle things like model fallbacks, potential of token caching, solving that noisy neighbor problem, those kinds of things that make sure that this system is actually robust. The third is, how does it actually get the signals that we use in our investigations? Well, that's where the React agent comes in. It's able to call tools. That could be an MCP client. I know that's been a big thing. Could be Python tools. Whatever works, really. Something that we do not show here is we do have to QA this as well. So this is a sensitive space. Regulators need to know that this is working soundly. And so part of this is keeping humans in the driver's seat in the first place. But the second part is we have a very rigorous QA process that's not actually depicted here. And boy, there's a lot of craze of having LLMs be judges, on many different use cases. For this project, though, we really want to keep everything needs to pass the human quality bar. And that means we need to have humans basically in the QA phase as well. So I'd like to see it become more systematic, but it's not really something that fits well into this diagram here. But it does exist. All right, so let's talk a little bit about the whole journey here, now that we're kind of through all the implementation stuff. This really started as kind of a moonshot idea. And interestingly, we spent all this time talking about agents. We knew agents were going to work for this probably in about less than a month. We set up a quick notebook to kind of demo how it might look on a few particular questions. Very impressive, I think, right away. And so we knew that this was going to be applicable. Quite frankly, I think that's what it really allowed us to kind of get the push to actually stand up this new agentic service, which was really necessary to actually make this happen. So we we went from this small notebook demo, fail fast, if you will, but it succeeded, and eventually are getting to this full enterprise system, totally, their own services stood up, et cetera. Really was miraculous. We also did this by having humans completely in the loop, not just during the review again, but also during this kind of really rigorous QA process to make sure that the agent's not hallucinating, let's say, or is providing sensible answers, or can be depended on enough. And we were able to finally get our initial questions out by the end of the half. Sorry about that. So let's look at another timeline here. We started with those notebook scripts in early Q1. That allowed us to know that this would actually work and was worth really investing in as a full-on product. We bootstrapped that agent service very quickly with that monolith. Just the bare minimum of kind of what we needed to get going, and we took it as far as we could, and it did well. Hooked that up with all the enterprise LMs, et cetera. By Q2, we finally got that first question in, which was huge. And I want to say, a lot of it was really actually working with the ops team to understand exactly how they were really going to get the best use of this as well. So that's a big component of this. It's not just the agent, unfortunately. I wish it was that easy. But really getting it to the bar of quality where a human reviewer is actually going to depend on it. Let's say it's like helpful 20% of the time. They will never look at it, and then you're just spending money on LLMs and getting absolutely nothing out of it. Maybe even 80% you could get that kind of reaction. And so it took a while for us to kind of work with QA, make sure this was done on Rails. We didn't want them just, going to a deep research-like interface, asking anything they wanted, because you don't know what it's even good at answering, right? So that was actually a big part of Q2. So we got that first question out. Q3, we started really trying to scale it up. So we started launching a lot more questions, looking into things like caching, where now we care about costs. And Q4 is where we've really already got a lot of the easier questions, maybe even a lot of the questions like before the review even starts that we can get. But now, if we're going to continue making gains, we need to actually be able to use context within the review to kind of build upon what we have. And so that DAG orchestration makes this a little more complicated, and that's something we've been kind of really plugging into in Q4. So we're really just scratching the surface with this, honestly. So what did we get for it? Well, one nice thing we have is we do have a little telemetry from the reviewer, so they can tell us if it's helpful or not. And what we're seeing is they're finding it about 96% helpful. So remember, I talked a little bit before about people need to trust this system to use it. So like if this thing's good, 30% of the time, 40% of the time, maybe even up to 80% of the time, in my opinion. They'll just learn that they are not going to get any use of it. They'll do all the research themselves. You're just saving no time. You spun up this very complicated system. And so like getting this kind of quality bar was a challenging process. And it took a lot of kind of human reviewer involvement, talking to the control owners, getting a sense of like what even human reviewers struggle with, when they're running these reviews and trying to build around that. So there's a lot of prompt iterations you can imagine to get there. Another thing is that I've talked about this a few times, but we managed to keep human reviewers in the loop. Outcomes of these reviews, they carry weight. And so you want to make sure that it's made in a sound way. Keeping a human in control of these at all times is, I think, a really good way to move along here. And doing this in a way where we can show a regulator exactly what the agent has found, how it found it, what tool calls it decided to make, what the result of those tool calls were. So we have complete auditability across anything the agent touches here, which is helpful. But all of this really comes to this number, which is that ultimately we were able to make this review wildly more efficient. So we measure the performance of the review as kind of like average handling time. How long does this thing take? So with just these initial questions that we're kind of front-running the research on, a human reviewer can spend 26% less time on average on these reviews as a result. So again, agents are not doing the work. They're not making the decisions. They're not automating really anything. But they're still able to see these massive efficiencies. And that is going to allow Stripe to keep up with user growth, maybe changes in requirements for the review as regulations change, et cetera. So that's been massive. So what are we going to do next? Well, we're working right now on kind of expanding that orchestration. We want to get deeper into this very complicated review. Another thing is, I don't know how far we're going to get with this, but I would love for like the kind of evaluations of how well the system is working to be a little bit more streamlined. I definitely think LLM judges per se could be a good way to like fail really bad models really quickly. I still suspect you want to have humans kind of in the loop in order to determine if it's really good enough to ship. The 26% reduction is massive, but it's just scratching the surface. Again, as we get deeper into this review, we can imagine this is going to get a lot bigger. And fine-tuning is really exciting. I don't know if we're going to get improved quality with fine-tuning. I definitely think we're just going to have more control of what we want to spend our time on and not be surprised by deprecation schedules, et cetera. RL is a fascinating one, too. Mainly because the answers here are verifiable. And so you can imagine like this end-to-end kind of training loop where you're actually learning like a superior brain to the agent that could maybe have less tool calls in the future, which saves context, et cetera. So that's a really interesting area, too. All right, so what did we learn as part of this? Probably the first lesson we learned is really just like splitting these very complicated reviews into these more bite-sized tasks that can really fit well into memory, that are very easy to judge if it's consistently good or bad. Remember, we have humans doing kind of the evaluations of if it's good enough. So keeping the tasks small enough is kind of part of the fight to kind of get there. The bite-sized task was absolutely critical to make really any progress here. To be anything more than a demo. And those bite-sized tasks allow us to do this kind of orchestration. So it allows us to actually start building upon context that's actually going to come up inside of that review, to be able to go deeper and to get to a point where we're getting more than just 26% reduction. Another thing was, infrastructure has been a big help. Certainly, we could not have done this probably without the agent service we had. It just was not going to be hacked into this ML inference system. It would have been a complete abuse of resources. And so definitely, don't be afraid of doing that. So what do I want you to take away from this? I would say don't try to automate everything right away. I think that's a natural instinct. Everyone thinks agents are just going to completely replace everything everywhere tomorrow, and that's just not how it's going to work. It's great to keep humans in the driver's seat. You should use these things as tools. They may not be actually even good enough to completely automate it. Who knows? I mean, the only way you're going to find out is to have a tractable way to incrementally attack some of these very long, complex problems into these kind of bite-sized tasks, in my opinion. Agents are great, and they're really amazing when you have almost an infinite amount of signals you could be baking into your answer, and you don't even know which ones to be looking at. Really, the tool calling is, I think, what makes the agents useful, maybe generally, but definitely for this project. You still need Rails for them, though. Because, again, you don't want an agent that's just spending all of its time on something you don't even care about that much, and not spending any time on the things you need to care about. And so that's why I think those Rails are kind of critical to this kind of incremental approach to those efficiencies. And the last thing is, do not be afraid to build new infrastructure, particularly for agents. Stripe's seen a lot of success. We have so many agents. You can imagine just how much we're using this now across Stripe. It doesn't have to take that long to build either. We had something in a month. And you could too if you don't have it yet. Maybe you do. So that's all I have for you today.
So I hope this was a good learning session for all of you, and you'll be able to take some of these learnings and implement in your own organizations. So we'll wrap up this session. Stripe team will be here to answer any of your questions that have been left unanswered. And one final thought is, Chrissy initially mentioned about the Stripe's Agentic Commerce Protocol, ACP. If anyone of you are interested in learning more about it, there is a session, I think it's on Wednesday around 2:30, so you can look that up and come there and meet some of the other Stripe folks who have been working on this protocol. And in the end, please make sure to give feedback in the app. That's how we improve. Thank you very much.